Greetings. Welcome to another video series entitled Equalities and Inequalities. This video series is brought to you by EMH Math Portal, and my name is Dr. Irvin M. Howard. Today I'm going to show you how to write interval notations involving subsets of real numbers. This is a series based upon students understanding how to write interval notations and graphing them. And most importantly, how to define an interval notation and how they can understand what the interval notation means to them. But before I start, I would like to identify two pieces of information that I will be talking about for this series or today's lesson. I will be talking about how to graph intervals and how to use the set builder notation. And this is important in understanding how the interval is defined by using the set builder notation. I'm going to start by starting with today's lesson involving the different types of interval notations. The first interval notation what we'll be discussing today is the open interval. And I'm going to explain the other types of interval notations in the upcoming video series. But today's lesson, open interval. All right. Okay, the open interval is defined by the set notation builder. And I'm going to give you the example and what defines the open interval. And it involves two numbers. And these two numbers are labeled as A and B. Now with the open interval in this case involves two parentheses, one on the left and one on the right. And on the left you have this number, which is any number which is A in the real number line system, and B, which is another number on the real number line system when you're graphing it. Notice the parentheses, how they're pointing. This parentheses on the left is pointing to A, and this parentheses on the right is pointing to B. Now imagine those two numbers, there exists a set of real numbers between A and B. And this is why it's called open interval, because we're identifying A as one endpoint and B as another endpoint. Okay. Now, with these two numbers exist an endpoint, there is a set of real numbers between A and B, and we're going to define this by the set notation, the set builder notation. Okay, hope you can see that. The set notation, or the set builder notation, is defined as X such that A is less than X less than B, and then close with the squiggly parenthesis. I call it squiggly parenthesis. But anyway, any number in between A and B, they're saying that this A is less than whatever number in between the interval, and then X is less than B. So if I have a number such as 4 and 6, okay? This is an example. Now, if I write this based upon the set notation builder's definition, this would be X such that this is A, 4 is less than X such as B, which is less than 6, and then close the set notation builder. This means that any number in between 4 and 6, they're less than, but X is less than 6. So this means that as an open interval, there can only exist numbers that are less than 4, and then this number is less than 6. All right. Now, primarily meaning that it doesn't have to always designate that 4 and 6 are equal, but as long as it's less than, all right, as long as whatever number between 4 and 6 is less than. And at the same time, the 6 represents the endpoint to where all the numbers will stop that are less than 6. This will begin with numbers that are less than 4. So it's really simpler, in simpler terms, to say that if 5 is in between, say like let x equals to 5, all right? So if we put 5 in between 4 and 6, 4 is less than 5, less than 6, okay? So that means that this interval fits the true statement. It's a true statement because 4 is less than 5 and 5 is less than 6. All right, so imagine a whole set of numbers in between 4 and 6. Now, when you graph it the same way that you see the symbols. All right, the symbol 4, just graph it on the number line. I'm going to say this is 4 and this is 6, just to identify just the numbers, and then this is 0. All right, the way that they appear as an interval notation, you just graph it the same way. All right, see, you have your parenthesis pointing to the 4, the left side of the parenthesis pointing to the 4. You put it over here. All right, and then you have your parenthesis pointing to the 6, which is the left side, just pointing over on the number line 6, and then just draw your line. All right, this represents the numbers existing in between 4 and 6. You have a whole set of numbers, and this is an interval between 4 and 6. All right, so remember that your values are based upon the endpoints, which is in the interval notation A and B, which are designated based upon the set builder notation. If you could memorize this set notation builder, it should be easier for you to graph any number or any set of real numbers that using the interval notation. And later in some upcoming videos, I will show you the set notation builder also can be defined as another type of set notation called the inequality notation. But let's do a couple of more, just to get you to understand what I'm talking about. Let's try some negative numbers. -2 and maybe +4. Okay, yeah, that's good. All right. Again, this is the open interval. Now, when we're talking about open interval, we'll talk about two numbers labeled or designated as your A and B. And the reason why they select A and B, because it's usually arbitrary. A is the first number on the number line, and B is your second number on the number line. And the way that you graph them, they appear in numerical order, regardless of whatever set of notations that you receive. Interval notation, they will always be in numerical order. Now, if I write this using set builder notation, x such that -2 is less than x less than 4. And then close my set notation. All right. Now, to graph it, okay, so any number, so we're saying x is any number between -2 and 4. All right. So if I graph it, I'm going to graph it 0, -2 on the left, +4 on the right. Again, the numbers will exist. Right side, left side, okay? A is left of B. B is right on the right side, okay? It's going to always be in that order, all right? Now, if I use the symbols, -2 is pointing this parenthesis, left side of the parenthesis. This left side of the parenthesis is pointing to -2. As I graph it, I'm going to graph over this parenthesis, the left side of the parenthesis pointing to -2. The right side of parenthesis for 4, +4 is over, it's pointing to +4, but I'm going to draw on the graph over the 4, all right? And then I'm going to connect the interval by drawing a line. That line represents the number existing between -2 and +4. So if I want to check it, all I have to do is just let x be any number. Let x equals to like -1, okay? So if I put -1, -2 is less than -1, which is just a true statement, because the smaller your negative numbers are, the larger in quantity, because your high, you know, your numbers that are your high numbers, they become lower in value. But the low negative numbers, such as, for example, -2, -10 is less than -9. -9 is less than -8. -8 is less than -7, so on. So as you get closer to the lower negative numbers, their quantity becomes higher until you get to 0, and then it becomes neutral. And then that's where you go to your positive numbers, which are already closer to your right, and we'll talk about that later. And let's try one more, and then this will be the end of the video. Let's try -5 and -1. All right. Again, you see this right here, -5. It's in the same numerical order when you see them on the number line. Okay. All right. So -5 comes before -1. So if I write it in set notation, x such that -5 less than x less than -1, and then close the set builder notation. All right. Now, if I want to graph it, okay, I graph it. I'm going to use 0 as the point, as the neutral point, to separate the, you know, just to show you how the number lines, the values follow on the number line. Okay, -1 comes here, and then you have your -5. Okay, and then you look at your parentheses. So this parenthesis is pointing to -5. So you draw your parenthesis over the -5 to graph it. And if you look at your right parenthesis that's pointing to -1, you do the same thing, but you put it over the graph. But it's the same way to point it. It's just an easier way to show it. You can draw it directly over the 5 if you want to. It depends upon how your teacher have you to present the information. And then you connect it. All right. All right. So I show you 2 examples of numbers positive and negative. And also I show you an example involving a negative and a positive value. All right. Okay, I hope this is helpful for you. The next video series, we're going to talk about closed intervals. All right, closed intervals, that's dealing with the brackets. So this lesson involves with the parentheses, which is called open interval, when you have 2 parentheses involving a subset of numbers. The next video will include the closed interval, which will involve a brackets series. The brackets for the subsets of numbers, excuse me. But I want to make one point clear, that when we're talking about the open interval, we're using the set builder notation as a definition to describe the behavior of the numbers following one after the other, A and B. All right, the first number representing in the interval 4, for example, if we go back here, is less than whatever the numbers between 4 and 6. All right, so we could say greater, but the set notation make it easier to say, you know, 4 is less than 5, 5 is less than 6, instead of saying 5 is greater than 4, 4 is greater than 3, and so on. By using the less than, we're able to maintain the explanation and also the appearance of how the numbers fall on the number line. They're falling in ascending order. All right, they're falling in ascending order. That means that they're falling in ascending order, they're increasing in value. When you're moving from 4 to 6, the values are actually being increased. But we're just describing that the predecessors are lesser than the successor numbers. Okay, you have a great day, and thank you for tuning in.